The hydrological cycle is when the topmost layer of the Earth's surface is heated by the sun's rays. It experiences a phase change because they volatilize and they evaporate and they rise and rise up to a point where they are losing the heat because of the dry adiabatic lapse rate of 1 degrees per 100 meters, and slowly these water vapors form a cloud. This cloud they are drifted because of the wind forces caused by the Coriolis effect, and after a point these clouds become so heavy that they cannot bear the weight of the vapors, and they will condense or experience a phase change from the vapor to the liquid state when they come in contact with hygroscopic condensation nuclei, which is in often in most cases the salt particles which are evaporated from the oceans. Whenever the droplets come in contact with the salt particles, they gain enough surface tension to form a bubble or a droplet, and by virtue of gravity these droplets will fall down towards the Earth's surface again. Okay, then they will, in some part of it, will always fall on the ocean itself. This is a water cycle. Some part of it will again say fall on land, and it will infiltrate because soil has a grain size distribution. Soil is porous. Infiltrate, and by the virtue of gravity, it will try to reach the groundwater table. Once it reaches the groundwater table, it becomes a base flow, and then it will again ultimately reach the surface waters, the open water bodies. Some part of it will infiltrate slightly below the ground and reach the ocean water body much before it reaches the groundwater table. Those are interflows. Okay. Some part of it will fall on the vegetation trees, and they will be temporarily suspended in these trees, canopy structures, roofs. From there, they are intercepted, we say, and after that they will fall down, ultimately infiltrate or evaporate again. Most of the precipitation is evaporated. Evaporation from the stomatal openings of the trees is transpiration. Evapotranspiration is a combined effect of both. So, hydrology, if we were to define, it is the tracking or quantification of the water in all these phases. The water is continuously depleted and repleted back because the amount of water in a system always remains constant, which is the principle of the water cycle. So, hydrology, it is the scientific study of the movement, distribution, and quality of water on Earth, including the water cycle, water resource, and environmental watershed sustainability. Say, if we were to track how much water is being lost, how much is being replenished, how water is changing its phases from liquid phase, gaseous phase, how it is evaporating, condensing. We are studying the hydraulics, the hydraulic behavior of water, the physics and chemistry of water itself, and the meteorology because the climate takes comes into picture, and all these allied branches of natural science branches, when we study we will call the cumulative study of all as hydrology. So that is why it is we have defined hydrology as the science that deals with the depletion and replenishment of water resources. Okay, it deals with the quantitative use of water on earth, and it deals with the surface and the groundwater. It deals with the occurrence, circulation, distribution, chemical, physical properties, reactions to the environment, and living beings. So, I hope you are following what hydrology is. You'll get better quality if you check our video with the hydrological cycle. Now, let us discuss what is the importance of studying hydrology. Like, where does this find application? Now, hydrology is important as a subject because we have to know the maximum flows year over year which are expected at the spillway or culverts in city drainage systems. Now, what are spillways? Firstly, spillways are artificial channels which are made to allow the passage of the surplus water from the dams. What are dams? Dams are structures which are built to impound water on the upstream side. Now, sometimes the discharge is too much. The water has to be let to the downstream towards the toe without causing overtopping or without causing any type of structural damage to the dam. we have to quietly or smoothly allow the water by opening the spillway gates, correct? We have to allow some water to flow on, surplus water to flow on the downstream. Okay, for that purpose, we will need to know the hydrology, that is the annual precipitation which occurred at the location. Then what is how to predict the precipitation in future for the next 30 years. Accordingly, we have to design the spillways. Okay, the maximum flows, and culverts are underground drainage systems to allow water from one side. It is usually below the embankments, roads, bridges. Okay, so to design them also so as to prevent damage to our structures which we have designed, we have to know the we have to know the maximum flows to appropriately design these hydraulic structures. Now another important structure is the levee. Levee, when we talk about, it is usually built between an inhabitation and a river. Now levees are artificially constructed embankments. They are like a weir. It has a crest at the top. It has a waterside slope, a landslide slope, and usually an impermeable core. It has several other parts to it. The purpose is very simple. Whenever there is a flooding in the river, it should not flood the habitation where people are staying. So we will try to, this impermeable core inside will try to disallow the penetration of this water on the side where the habitation lies. So this is the purpose of a levee. For that, we have to know the maximum flows which can occur on the river. So everything we need to study: the meteorology, the nature of water, the precipitation, the hydraulics. It is a, say, and comprehensive knowledge. Hydrology is a comprehensive knowledge of all the everything dealing with water, like a quantification of water. Okay, so we have to know the maximum, in order to know the maximum reservoir capacity which is required for adequate irrigation and municipal water supply, to design the rainwater harvesting systems. Now, what are rainwater harvesting systems? Let us quickly look. It is, say, as the name suggests, we are harvesting the rainwater, which falls on the roofs. The area over which the rainfall is captured, we call it a catchment. Okay, these catchments we have to know. Then it is taken from through the help of these piping, these cast iron pipes, to the filter, because the first flush will usually carry all the contaminants, atmospheric contaminants. We will filter it first before use. Then we'll send it to the main tank with the help of a pump. This water will be delivered for various communal purposes, domestic purposes, daily life purposes like clothes washing, toilet flushing, gardening, car washing, and whatever overflows from that will go to the well, and that will recharge the groundwater. To uh, to achieve groundwater recharge, a well is also kept here, because the more groundwater is recharged, the better is the water availability throughout the year. Correct. Then another situation where we require the study of hydrology mainly is for the what underground drainage system, usually in urban areas. This system usually again collects water from the catchment or the roof, and from a stormwater pit. Usually these pits will have a casing. From that, water is collected. Where does this water go? From both the sources to a subdrain. Through the subdrain, say it is made of some materials like asbestos, PVC, cast iron pipes. Then these subdrains goes to the curbside drains. Okay, curbside drains will let all the water inside the stormwater drain. These are the drains which then connect to the major stormwater drains which are laid underground our roads, underground underground our structures, and from there it is let the rain runoff, the rainfall discharge goes into the lake. To design this system efficiently, we have to know, then have the knowledge of hydrology, correct? Then another application where I hope you have heard of watersheds. The integrated watershed management. Watershed is any structure, any area, say, which is usually bounded by the highest ridge line here. It will serve. to serve the purpose of collecting the runoff which is falling on all this area and usually will flow into a common open water body. So all the area which contributes water to this water body, river, lake, we will call it a catchment. Now there are several aspects of the integrated watershed management. To manage watersheds, we have to take care that all these systems related to it are working correctly. For that, we have to know the hydrology first. The knowledge of hydrology is most important. Correct? So these are some applications. The we have to also another importance is the supply sources at the reservoir site, the effect on water levels after construction of proposed reservoirs leaves. Correct. Then, as we have seen, groundwater recharge, watershed management, and the stormwater drainage designs. So these are the several applications of hydrology. Like these are the importance. Now, again, to summarize, if we were to say where hydrology can be applied, mostly in water resource planning to plan the development of dams, reservoir, canals, to estimate the surface and groundwater availability. Correct. Lots of structures design depends directly on the availability of groundwater level. Okay, and the surface water bodies nearby. Then for irrigation and agriculture to determine the water requirement of crops and aid in designing the irrigation systems and schedules. Correct. In flood control management, like we have seen with the help of a levee itself, that we have to predict the floods and especially in culverts, correct, and dams, we have to assess the flood risk and to design flood protection measures like levees and flood forecasting systems. Another application is the urban and rural water supply to locate the water sources and assist in designing the storage tank, pipelines, and treatment facilities. Correct. Then hydropower generation to estimate the stream flow for hydroelectric projects, their operation optimization to predict how much electricity in mega million electron volts we can generate. Now, the environmental protection to assess the impact of water pollution and propose control measures and thus maintain the ecological balance in rivers, wetlands. Then drought analysis and mitigation to analyze rainfall data to predict the droughts and aid in creating early warning systems and drought management plans. And again, always in climate studies we require hydrology, like to examine how global warming is impacting the rainfall, glaciers, river flows, and to suggest the mitigation strategies for them.